Come on.
Okay.
Maybe people could
Yeah,
see
IRC on.
live.
Could you ask an IRC?
Yeah. Do you have IRC on? Okay.
I haven't heard from anyone yet, though.
Yeah, it's probably going to take some time to respond. And let me make sure that I've invited the person who asked. Okay.
Did you ask an IRC?
Yeah, just asked. No.
Nope.
Okay. Okay there. And
He said nope and then okay.
said,
You didn't hear us.
usually Matt does this stuff, so it's going to take some. Okay, so he's able to see the Q&A. That's good.
So Matt's on vacation, is that the?
Matt is on vacation. Yes.
I thought the novice is running the system here now.
You might even just send the link, like this link out, so they can join in the video if they want.
Oh, on IRT.
What's up with the beat? Jeff Hawkins dude on the right?
Sounds
Does
fine.
that mean I look beat? Does that mean was there something?
There was
Yeah,
a
look
link
good.
that was shared earlier. Okay, so there's 3 viewers. It says right there.
Okay.
Okay, so I think people can hear us and they can see the Q&A.
You're muted? You're muted.
No, that's not. So the microphone is here and the speakers.
Okay. Great.
All right.
So the people that are watching should start putting questions in if they have them.
Yes.
Okay, that's good.
Okay. Oh, I don't know why. Oh.
No. Cognition. What does that mean?
Just put this link in.
To the Hangout?
Yeah.
I need to make sure that.
Obviously, some people are in.
Yeah. There's 5 years. Good. We can start with
That's
some of
not-
the updates.
That's the peak Jeff Hawkins.
Yeah. Oh, that's the that's it there. They don't have a live picture, or do they?
If they click it, it will be.
All right.
That's just a screenshot.
Got it.
Okay.
All right. What are we talking about?
Okay, so the topics that were suggested for this office hour so far are, let me find that. Okay, the new encoders, the geospatial and coordinate encoders. Virgil mentioned that it would be nice to have a Q&A session with us. There's the new temporal pooling and sensory motor theory, maybe a review of that and update where we are. And any questions, an update and any questions on the new temporal memory implementation that was recently merged to NuPIC.
Okay.
This is the initial set of questions, suggestions, and
Now we just did a whole thing about the.
Yeah, we've done like 3 different things with the geospatial encoders. Was there a specific set of questions, or is it?
no, there wasn't
Or-
a specific
or,
set. It was just like questions that people may have.
That was a suggested topic.
Suggested
Suggested
It
topic.
wasn't a particular question.
Yes.
So if people have any questions on that, they should
Ask,
us.
otherwise we're not going to talk about it. 'Cause, we just did a nice big talk about that.
Yeah, and we did another, the previous office hour, you showed stuff, and then Matt did a tutorial on it.
Yeah. We could just jump in to start talking about where we are, the status of the new implementation of Temple Cooler and the Temple memory.
So someone someone said that they can't. Nothing's happening on Google Plus. How do I do
So that's, are you trying to look at this online?
No, I wasn't. They told me to log in.
Okay. Would you be able to just check out? Oh, I guess. Oh, that's different. So I can send you a link.
Okay, send the link. Try it.
Send you an email.
So
See if you can see.
it just got muted up there.
This is the microphone. We're using this one.
Oh, I see. And I don't understand why we're not seeing. Oh, that's what they'd be seeing.
Yeah, this is what it should be seeing. But I sent you the email.
Okay.
Let's see if.
All right, we're still trying to get this
It's my
working.
Outlook or Gmail. There it is. All right, let's see.
Did anyone? Is it
I see
working?
you guys.
Okay, I got a question on the Q&A, and you can see
Okay.
this.
All right. Well, some people can see us. So,
Okay, good.
all right.
So we can select
Okay,
that.
so I got, there's a question from Cognition. I'm mostly interested in the status of the new temporal pooling stuff.
So if you select it, it shows up. Right?
Good. So is there a particular question?
Well, we could just talk about what we're doing, right?
We can start with an update.
You want to go through just like who's working on it and where we are?
Okay. So in terms of the new temporal pooler stuff, we've been working a little bit internally over the last month or two with our intern UA, and he's been trying out sort of some of the initial versions, initial implementations of the basic idea. And what we have is, what we're trying to do is have a system where we have a random maze, and there's a little sort of a controller for the maze and a world around the maze, and there's a little sort of virtual agent in there, and the agent can move around in there and get new sensory input as a result of its motion. And the basic task is to try to figure out from the motions and the sensory patterns and the motor control signals that it's generating to build a predictive model of each maze. So every maze would have a different spatial configuration, and by moving around in it, the system would quickly build a predictive model of it. And with the temporal pooling stuff, what we're trying to do is create an overall stable representation that is unique for every different maze based on the predictive model that the agent builds of that world. And so the end goal of that should be, if everything works well, is you'd be able to throw in dozens of mazes, hundreds of mazes. You have a little thing that's moving around and very quickly figure out, based on its motor control and its predictions, exactly which maze that happens to
And
be.
form a stable representation.
And form a stable representation.
So
A unique stable
So
representation.
we're using the new temporal pooling algorithm on top of the new sensory motor inference algorithm,
Yeah.
as opposed to over the high order sequence learning.
Right.
And I think I should point out that although Subutai says we're mazes, it's done in a very generic way. Those, we should have a visual on this, we don't, but the mazes are really just, they can be any topology, but we're creating them in some sense like a 2D matrix. And so we have it as a test bed, we can move from calling it a maze to calling it vision experiments. It allows us to move from very simple problems to much more complex problems where the motor commands and the sensory input vary dramatically, and we can ultimately get to a vision system with saccadic behavior. So it's a continuum, it's a test bed that will let us go through that continuum. Also, I think it's working to a large extent. It's exhibited the behavior that we want it to exhibit. It's able to learn different worlds and form stable representations of them. And we haven't tested it to extreme yet. We've only done with a few mazes at a time, but it is working.
Yeah. I think the basic mechanisms for it are exactly what you described at the hackathon and in previous discussions, which is as soon as you're able to start building making predictions, you pool over representations where you're able to predict the sequences. And that's the basic rule under which you start pooling together representations.
So yeah, it's I can't remember where we last described it, but basically, yeah, if the model is predicted, then the next layer in the system will basically keep the same cells active, and it'll start learning all the different components that are together predictive, and they therefore together represent the same cause in the world.
Yeah.
So that's the mechanism we're using, and it's so far we haven't seen anything that's too worrisome about it.
Right.
I think we're pretty happy about it.
Okay.
So that's a pretty kind of high-level description. You know, I know UA is in the process of writing up some of his summer work, and once he's done, maybe we can send out a version of that out to everyone.
I think there's
a related question,
Yeah.
or the follow-up question is there any progress on the hierarchy implementation and testing / coding?
Yeah, so the plan here is we're going to build, we're going to test hierarchy and implement hierarchy on the same test bed we just talked about. So again, we're going to talk about using sensory motor inference with pooling and do that in a hierarchy. So when we start, imagine if you're trying to apply this to a vision problem, what we're trying to do is say, looking at some pattern in my visual input, which is like a room in a maze or something like that, and I have a motion to move in another direction. Can I make a predictive, can I build a model that predicts what I'm going to see? And you very quickly will discover, if you try to do this over an image, that you can't, there's a limit to how far you can move and make correct predictions. That if you want to move your eyes to the right a little bit left, a little bit up and down and so on in different directions, no problem. But you start going further and further, then you run into a combinatorial explosion. So, but the way the brain solves that, we believe, the way we're going to try to solve it too, is we're going to see how much of a sensory motor predictive model and pooling we can do in a single layer, and then we're going to then take that input and put it to the next level in the hierarchy. So we don't expect to be able to do this all in one level of hierarchy. We know we can't. But this is going to be our test bed for hierarchy. Again, focusing on the sensory motor plus pooling, and then do that in a hierarchy. So we haven't done that yet, but we don't anticipate problems, but you never know.
And the basic, one of the problems that have to be solved in both cases is this ability to create a representation that is stable and yet unique across many different changes. So you need, as you go up the hierarchy, you want representation that get more and more stable, but at the same time are differentiated from all the other stuff that is not represented by the concept.
Yeah.
And that core algorithmic piece is the same in both of these tests.
Yeah. So we're not committing to doing this, but we might go down the path and just keep going until we build an image recognition system based on saccadic motion, and but that's not where that's just a good test bed. We're actually I'm anticipating some rather cool applications that can be built in sensory motor integration and pooling that have nothing to do with vision. But so we're starting with mazes, moving towards vision, and then we'll see where we go with it after that. But hopefully this won't. The progress is steady. It's not stock or anything like that, but it's not super fast either. You just everything has to be tested methodically. Go back and check assumptions. Make sure we understand the limits of what we're doing before we go on to the next thing. We just don't you just can't throw this all together in one fell swoop. So you have to be pretty methodical about it as you build this up and test it and understand how it works. So I think I'd say in general we're pretty happy with how it's going, but it's it's going to be a little while.
Yeah.
Okay. Related question: will the TP also output path choices to the agent?
Okay, so that's I like to break down the issue of motor generation or behavior into two parts. The first part is, how do I just build a model of the world given a copy of the motor commands and the sensory input I'm getting? And this is not generating behavior in the cortical model itself. There's something subcortical generating that behavior. And yet we still should be able to build a model of the world. The second question then becomes, how does the cortex itself generate behavior? And how does it influence the subcortical, the thing further down the hierarchy, to have it change its behavior, do something cortically smart in its behavior as opposed to something dumb? So right now we're just saying, hey, we have some motor system that the cortex is not controlling, and that's okay, and we're going to learn to build a model of the world from that. But it's not generating the behavior itself. That's the next stage. So we don't have a full theory on that yet. As I've talked about before, we have pieces of the theory, we understand a lot of the components, but we don't have the whole thing yet. I'm hoping to have, as we go through this process, I anticipate but can't promise that we'll have the basics of that whole theory put together. Not too distant future. It'd be nice by the end of the year, maybe it'll be earlier, maybe a bit later. It's hard to know. But it feels to me like it's not very far away. But today we don't have that. We just have components of that theory. So we're not trying to do that right now. Wish I knew the answer.
Okay. There's the suggestion. I don't see any more questions on the Q&A widget. Feel free to keep bringing them on. As for the other topics, there's the new temporal memory implementation that's in NuPIC. Maybe we could do a quick update on that since we haven't really sent anything out about it. We kind of just merged it. It's still...
Why don't you explain what it is exactly?
Okay. So
why we're doing it, in case some people don't remember.
Yeah. So the current implementation of temporal memory, which is currently confusingly called tp.py in the code, it's developed. So it started with a white paper implementation, and more things have been added to it over the years. Things like backtracking and start cells and PAM. So it makes it confusing to understand when you're trying to read that code. So we have worked on implementing a clean, pure version of the temporal memory, basically one that reads more like the white paper and is easier to understand for new community members, and also easier to experiment with. So it's more understandable what's going on with it, which means we can use it in our experiments with temporal pooling, since it's a foundation for temporal pooling and sensory motor inference. So this is an implementation that can be the basis of further experimentation.
It's a new Python implementation, right?
It's a new Python implementation, and eventually our goal is to also make a corresponding C++ version for performance reasons. So there are some slight changes from the white paper in terms of the way it functions, because the white paper hasn't been updated in some time, and we're still currently testing and optimizing it for various cases. So that's still ongoing. The implementation is there. There's some initial tests, and it's merged, but we're continuing to work on that. And
so is that available on NuPIC?
That's available.
So people can look at it now.
Yes. In fact, a community member actually ported it to Java.
Oh, already, huh?
And
we're not even finished with the Python. They ported it to Java.
So yeah, so active work is going on that, and we will be, we're aiming to use that in our further experimentation with temporal pooling.
Is it a reasonable question to ask, like, how soon will it be done? Is that even a good question? Is it never done?
Which part?
Now you're going to...
Just the temporal memory.
Yeah, I mean, if people are interested in this, when do we say, yeah, go for it, use it, or when do we integrate it back in, or what is the time scale by which this is, how far are we close to wrapping up that project, and does it ever wrap up? I'm just trying to get a sense for that.
Well, the initial implementation is down, it works. We're not confident enough to switch over in our production products, but
so we think it's good enough for people to use.
Good enough for people to use from a work standpoint, but we don't know how well it performs. Is it going to get the same prediction accuracy? Are the data scores going to be good? We don't know.
Yeah, and we're still doing some testing on those kinds of things, adding more tests and really trying to validate it. That's still in progress.
So I mean, one milestone would be when we integrate it back into the core of NuPIC, right? That's a bit of ways off.
Yeah.
But also the next an earlier milestone.
Probably.
Yeah.
I think an earlier milestone would be that we're also working on integrating it with our sensory motor experiments.
Yeah.
So trying to use.
Yeah. So I was going to work back. The ultimate is it's totally folded into everything. And earlier than that, we're going to use it for the temporal pooling and central motor experiments, but other people can use it too.
For their experiments.
When are we going to start using it for our own experiments?
Well, I don't know if UA is already using it or not, but we want to switch over as quickly as
we're
possible.
not really, it doesn't really not waiting for anything.
No.
So it's basically, if someone else wanted to do some experiment with it, it'd be good too, because it's ready for that.
Another thing we talked about doing is to make it accessible within the OPF, so that as an option, people could use that implementation instead of the old TP implementation.
But wouldn't the old one go away some point in time?
At some point in time, our product Grok is using it, so moving away from deleting it completely is actually a fairly big task from a product backward compatibility standpoint. But I think our intent is all new development will be on this new code base.
Okay.
That's the current question, which we are kind of answering, just want to make it explicit, is so the old TP won't be abandoned, it's just to put to the side in favor of the new TM for understandability.
Yeah, I'd put it maybe slightly stronger than that. It's not that it won't be abandoned, it'll be deprecated, and so the intent is eventually to get rid of it.
But
if that makes sense.
If you want the best prediction performance right now, the TP.py is probably still your best bet.
Yeah, because it's being really optimized and tuned, and all the parameters and everything are set to work well with it.
I also want to make it clear that the current implementation we're still doing tests on, still validating.
The current mean the old.
The temporal memory implementation, the new one that we just merged to NuPIC, still being tested and validated in more realistic and end-to-end test cases. So still doing that. So the current TP.py is the one you'd want to use for if you're trying to get good prediction accuracy, reliable prediction accuracy.
Yeah.
Okay. But if you're doing experiments like we are, you might as well use a new one.
Then
I mean, we don't know if the new one's not as good yet, do we? Do we know if the new one's?
Yeah, we don't. We just
don't. We just can't vouch that it's as accurate.
Yeah, right. But
it might be better for all we know.
Yeah.
We don't know yet.
Until it's in the OPF, we won't be able to test it out fully.
Yeah.
So that's another milestone is if we can get it working with OPF.
Okay. We got some other questions here.
Okay. Let me actually try to pick the one that's most. I'll go in order of.
This one came
of relevance.
Should I go in relevance or in terms of?
It's up to you. You're the moderator.
Yeah. Whatever. You're that.
Let's do relevance so we don't do too much context switching. Is there an updated white paper / natural language pseudocode for this new temporal memory Python code?
Who asked that question?
That was Ryan Shams.
Because that was just on the mailing list. That's why I asked. But no.
The answer is not.
Yes.
No.
Is there plans to have something like that?
I think we should.
Yeah,
I think we should. The people have found the pseudocode to be really helpful, and it would be great to update it and have a sort of a concise description of it.
Who would do that? Would Shaden? Would you do that?
Yeah, I've been actually already documenting the changes, and I have a pseudocode version of it in my design document, so I'm like halfway there.
Yeah.
So we could do that. Yeah.
Yeah. We should get it reviewed, and then just.
Yeah.
I think it'd be very helpful for the community to have.
Okay.
Yeah. So we will work on that. Okay. So now this will be a new topic, so I'll just go sequentially in time. The question is, I'd like to work on more complex audio signals. Is there already a more complex audio sensor than the simple one-track wave file processor in GitHub? So I start from best current point with new building for both music processing and language audition.
I don't actually know the
I don't
answer.
know the answer to that one either.
Well, I can start answering it. The NuPIC.critic is probably a relevant topic point of discussion here. Matt has been working on some audio processing with NuPIC experiments.
When they mentioned an existing encoder, that's not what they're talking about?
It sounds like they're asking about encoders, like an audio sensor than the simple one-track wave file processing in GitHub.
Probably is NuPIC.
That probably is NuPIC.
Oh, okay.
Is that what Matt did?
Yeah.
Yeah.
Then that might be.
Then there is nothing else, right?
No. We haven't really done any official audio works.
No.
So there's the work that Matt did, and
Rich, what would you like to see? I don't know
Maybe.
if maybe you can't answer immediately, but it'd be interesting to know what you'd like to see. And it's an open source project, so
Or maybe
feel free to build one.
Yeah, build one. We have very little audio expertise here.
Yeah.
So this is not an area we've been focused on or have experience in.
I think it'd be great if eventually there was like a MFCC kind of filter on wave files so that we could output, null coefficients, stuff like that. That's kind of the state of the art, I think, in speech. Or other similar filtering techniques would be great.
So he just clarified, yes, I'm talking about the encoder in NuPIC.credit.
Okay, right.
So that, to answer your question, that would be the best current point to start doing more work with audio.
But it would be great to hear about what more you think should be in there so that you could do music processing and language and other stuff better.
I always continue to believe there's in the encoder space, there's tremendous room for creativity. We saw that with Cortical I/O doing the word stuff. I think we did some pretty clever things with the geospatial encoder. I think there's possibility to do something interesting in audio that may be beyond what the standard stuff is. Could you do something like what Cortical I/O did and make some sort of audio retina? I don't know, but there's opportunity for creativeness there.
Yeah. Looks like there was an answer.
Yeah, he just clarified. He would like to make his own, just wanted to know the best starting point.
Okay, well that's it.
Yes, real MFCC like that. Okay. Great. Yeah, we'd
Love it.
look forward to seeing that stuff.
Yeah.
Keep the mailing list posted on your work. Okay, a question from Scott Jordan. Is there any work being done to turn NuPIC into a multi-threaded application?
As far as I know, there isn't anything right now. It would be great for someone to look into that and try, I guess it would be NuPIC core, trying to see what the ins and outs of that are.
One potential way to do that is in the network API. There's already sort of isolation of different regions and implemented separately, so you could do each of those on a separate processor.
Oh yeah, that would be an easy way to. That'd be a good way to do it.
What's the main advantage of this in this case?
Probably speed ups and scalability.
Scalability of multiple cores, is that the idea? Yeah. I mean, we haven't done that in the past because, I don't know why.
Well, we did that, long time ago.
Yes.
Several years ago, and then what we found is our bottleneck was really
swarming
and training lots and lots of networks in parallel for the parameter optimization.
Yeah. So I'm not sure. I'm just trying to get it. Do we think it's a promising thing to do, or would there be a lot of returns on it?
I think some sort of multi-threading, particularly at the region level, could be really helpful.
You can imagine if you have four, especially once we get the hierarchy.
Yeah, that's what we did it in the way in the past. We did it with hierarchy. That was we found that was a good breaking point. It was this okay breaking point.
Yeah.
And so we could. You're saying that we get back to that.
Yeah, trying to break up a single temporal memory instance, for instance, the benefits of that are a little more dubious to me.
Yeah.
But
across regions or across layers, that could be very cool.
Okay. There's no more questions on the Q&A. Another topic that we could talk about is that was suggested is what's up with the naming.
You didn't tell me about that one, Chief.
I did not. Yeah,
I surprised us on that.
Is there any maybe we can just
seems like it's
mention
converged for the most part.
mention where we are.
Well, we have started adopting temporal memory and temporal pooling, for the temporal memory being the sequence memory, temporal pooling being pooling. So logical names. They aren't sexy. They don't roll off the tongue very well, but we started using it. Seems to work pretty well. All I know is we have a summer intern here in the marketing group, Nick, who was writing these white papers, and he couldn't figure out how to get these temporal memory to work, so he went back to using CLA. So it didn't work for him in the marketing literature. So I'm not sure if we've seen the end of this yet.
Yeah.
But it's the engineering side of things, I think we're okay on those two. I realize this is a bit controversial, and not everyone agrees with it. Virgil, I'm talking to you. But we can't spend our lives on this. We have to keep going. So I feel okay where we are right now, and I think it's important for us to leave room in the naming scheme to have room for new things and additions, and you know, so that's one of the things we've been trying to keep options open. But it wouldn't be surprising if sometime in the future we have to go revisit this again.
And within temporal memory, there's the motor and the higher order. What are we doing?
Well, the way I view it is temporal memory is the same mechanism for sensory motor inference and higher order inference. So I would say we can use the temporal memory for sensory motor inference. We can use the temporal memory for high order inference. We can use the temporal memory for motor sequence playback.
Sure. And if we wanted to talk about one of those specifically, what would I say? Like
I would probably just
layer 4.
You know, layer 4. That's a really interesting question. I have always liked to talk about in terms of neuroscience, and that's how I think. But most people, that doesn't work very well. So like we're writing some marketing literature stuff here. I'm trying to avoid talking about layer 4 and layer 3 because it doesn't mean anything to most people. And so we can just talk about, well, the cortex does sensory motor inference. You know, the cortex does high order inference.
Yeah, it's funny. Even to most neuroscientists, talking about it in terms of layer 4, layer 3,
Yeah.
a lot of them don't realize those aspects of the.
They have no concept of what layer 4 does versus layer 3. They think layer 4 is, oh, that does, you know, simple cells, and layer 3 does complex cells, you know, that kind of thing. So, but that's vision. It doesn't apply to other things. So yeah, it's a problem. So we're still struggling as an overall, you know, in the Menta. One of our, you know, challenges that we've described all these learning algorithms in the language of neuroscience, but for many machine learning people and others, that is not useful for them. And so it's a challenge to come up with the right language that can speak to the machine learning community and others, and somehow address the neuroscience community. And so we're struggling with that. I don't think it's broken right now. I think we're okay for now. But I wouldn't necessarily decide. I wouldn't jump and say, well, here's a layer 4 function. I would say we're doing sensory motor inference. That's very descriptive. We're doing high order sequence inference. That's very descriptive. And then only when you really start thinking about neuroscience can you say, well, okay, well, I'm proposing that's layer 4 and layer 3. But that's a secondary description for me. I'm moving more towards those generic terms. You know,
Works for me.
but you know, we're open to suggestions on this. Well, to a certain extent, everyone wants to write it some way different ways. But we'll listen to suggestions. We may not always adopt them. But that's the same with everyone else too. They don't adopt it. We say. Okay.
Okay.
That's it for
all
today?
the questions?
Could be a short office hour. It's fine with me.
I think half an hour is what it was.
Good.
Yeah.
Excellent.
Okay.
All right. Well, thank you for the questions, and for those of you who are watching later, thanks for watching later.
Thank you.
Thanks, guys.
Bye.